Hello dear students, Assalamu alaikum. I hope you will be fine. My name is Engineer Mir Masood Shah. I am lecturer in Department of Technology, Sadr University of Science and Information Technology, Peshawar. As I am teaching you the subject Design of Hydraulic Structure, today is your lecture number 23. In lecture number 23, we will continue the topic about falls or canal falls. We have already studied about what is canal fall, and also we have studied some types. The remaining types we'll study in this lecture. So coming to the topic, the other topic of canal falls are stepped fall. The stepped fall consists of a series of vertical drops in the form of steps. This fall is suitable in places where the sloping ground is very long and requires long glacis to connect the higher bed level to the lower bed level. As you can see in the figure, this fall consists of a series of steps, a series of vertical drops connected in the form of steps connected with each other. This fall is suitable where the length of sloping ground is very long and requires long glacis to transfer the higher bed level to the lower bed level. This fall is practically a modification of the rapid fall. Also, the sloping glacis is divided into number of drops so that the flowing water may not cause any damage to the canal bed. Brick walls are provided at each of the drop. As you can see in the figure, brick walls are provided on each of the fall. Also, rubble masonry is provided between the brick walls in order to protect the bed. The bed of the canal within the fall is protected by rubble masonry with surface finishing by rich cement mortar of 1:3. This rubble masonry is the surface of this rubble masonry is finished with rich cement mortar in 1:3. The water comes from this here and it drops here, then they travel this distance and then drops again. So step by step the water drops or falls, and the required higher bed level is transferred to the lower bed level. And this way this step fall works. The next type is the trapezoidal notch fall. In this type of fall, a wall is constructed across the canal. As you can see in the figure, a body wall is constructed across the canal. The body wall consists of several trapezoidal notches between the side piers and the intermediate piers or pier of piers or piers. As you can see in the figure, trapezoidal notches are provided between the side pier and intermediate piers. The sill of the notches are kept at the stream bed level of the canal. This sill level is kept at the upstream bed level of the canal. The body wall is constructed with masonry on concrete. An impervious floor is provided to resist the covering effect of the falling water. Also, the upstream and downstream side of the fall is protected by stone pitching finished by cement grouting, and the size of the number of notches depend upon the full supply discharge of the canal. So this is the working of the trapezoidal notch fall, or this is the works required for trapezoidal notch fall. The next type is the vertical drop fall. This fall consists of vertical drops wall which is constructed with masonry works. The water flows over the crust of the wall. As you can see in the figure, the water flows over the crust of this wall. A water eastern is provided on the downstream side, which acts as a water cushion to dissipate the energy of falling water. This water eastern is provided, or water cushioning is provided, in order to dissipate the energy of this falling water, that the water can easily or slowly move over the bed of the downstream side. A concrete floor is provided on the downstream side to control the slowing effect of the flowing water. As you can see in the figure, concrete floor is provided on the downstream side Curtain walls are provided on the upstream and downstream side. Also, curtain walls are provided on the upstream and downstream side. This concrete floor is provided in order to resist the scouring effect of the floor. The stone pitching with cement grouting is provided on the upstream and downstream side of the fall in order to protect it from scouring. As you can see in the figure, stone pitching is provided on the upstream, also on the downstream side, in order to protect the bed of the canal. Next type is the Glacis Fall. The Glacis Fall consists of a straight sloping glacis provided with a crust, as you can see in the figure, that the straight sloping glacis is having a crust. A water cushion is provided on the downstream side to dissipate the energy of flowing water. This is the water cushioning, which is provided in order to dissipate the energy of flowing water. The sloping glacis is constructed with cement concrete, as you can see in the figure. This sloping glacis is constructed with cement concrete. Curtain walls and toe walls are provided on the upstream and downstream side. These are the curtain walls provided on the upstream and downstream side. The space between the toe walls and the curtain wall is protected by stone pitching. This is the stone pitching which is provided between the toe walls and the curtain walls. This type of fall is suitable for drops up to 1.5 meter. This fall is suitable where the fall or the difference between the upper bed level and the lower bed level is about 1.5 meter. So this type of fall is suitable at that place. And this is the end of our today's lecture.